All right, let's look at this first one. It says, circle all of the figures that have a correct line of symmetry drawn. Now in our case, we're just going to go ahead and use these check marks here. We're going to take another vote here. Yes, Ezekiel.
Do we do this?
No, like I said, you don't have to open anything up or go anywhere. You're just going to look at my screen and we're going to work together on it. My first shape, the triangle. Let me zoom in a bit. We're going to take a vote here. If you think that this line here shows me a line of symmetry where I could get two congruent parts, I want you to raise your hand. For this triangle, did they draw the line of symmetry correctly? Okay. This line absolutely did correctly. I'd have two congruent sides of that triangle, so it's done perfectly. Let's move on to the next one. Okay, I've got a star. It's got a line of symmetry drawn on there. So if I took my star and if I folded my shape on that line, they're saying I would have two congruent parts, two parts that are the same size and the same shape. Raise your hand if you think that this has a correctly written line of symmetry. This one doesn't. Who can tell me what's wrong with this? How did they mess up this line of symmetry here? Violet?
Wait, do we like get it on our page?
No, like I told Ezekiel and like I said before, this one, you're not opening anything up, you're not going anywhere. We're all just going to work on mine.
Okay, so one's one of the sides has three little points and the other has two little points.
You're right. One side of the shape, if I folded it over, would have 3 points. The other one would only have 2. And that's not congruent. It's not the same size, same shape. So no, that star is not, doesn't have a correct line of symmetry. What about this hexagon? The way they drew the line there, if I folded the hexagon or I cut it into 2 pieces, would I have 2 congruent pieces? Raise your hand if you think yes, I would have 2 congruent pieces, 2 equal pieces. Okay. My hexagon would absolutely have 2 congruent pieces. Both sides of that hexagon would be the same size and the same shape. So that's a correctly drawn line of symmetry. This one, it's not really a circle. I mean, I guess I'd call it like a Pac-Man. Okay, so this Pac-Man. I took this Pac-Man and I used some scissors and I cut it, or I folded it, and I used that line. Would I have 2 congruent pieces of Pac-Man or not? Raise your hand if you think yes, I would have 2 congruent pieces of Pac-Man. Okay, this one is congruent. I'd have 2 congruent pieces of Pac-Man here. Because even though this part is missing, it would be missing on both sides. So they would still match perfectly. What about this shape, this arrow? If I were to take a pair of scissors and cut it on that line, would I have 2 congruent pieces? Or would I have 2 different pieces? Raise your hand if you think that this would be congruent. 2 sides that are the same size and same. No, not this one. I'd have one side that has a bend and the other side is just a straight line and an arrow. The other side doesn't even have an arrow. What about this one? If I folded it or I cut it there, would I have two congruent pieces? Or not? Raise your hand if you think yes, they would be congruent. Okay. This one, no, I would not. So let me show you. Each one's got a point, correct? Fantastic. But if I were to take this shape, and if I were to fold it, use a line so I can look at where this point's going to end up, right? I'm right on the point. This line, or that point, is going to end up right there. So this point won't line up with the point on the other side. It'll end up next to it. So even though they both have a point on each side, they wouldn't line up. They wouldn't be equal. They would be close to it. They would almost have the same shape, but not exactly the same shape. Whenever they have any kind of shapes with like diagonal lines, you have to be very careful about symmetry. Sometimes it looks like it would be close, but it doesn't always work out. And again, with straight up and down lines, it's usually simpler. You can see it a little more clearly, but with diagonal lines, kind of hard to see, but they won't always line up the way you think they would. Like here, the points wouldn't actually line up. They'd end up next to each other. Kind of look like, I don't know, little bat ears or something. That's not what I want. I want two things that are exactly the same, like looking in a mirror. So here, are lines of symmetry. The good thing about having a line of symmetry is if you know that a shape has one, you can actually finish a shape that's not done yet. I'm going to use some thicker lines here. Okay, so since I know this is a line of symmetry here, which means that this side needs to be equal to this side, I can actually use that line of symmetry to finish the shape that they started. Now, since it has to be the same size and the same shape, I'm going to use the squares to help me make sure that I don't make one side smaller or bigger. So this line, it goes for 1, 2, 3, 4, 5 squares. I'm going to start here. 1, 2, 3, 4, 5 squares. My line bigger. That way it kind of matches. Okay, there's one part of it. We're not done though. So it goes that way, and then it turns. 1, 2. 1, 2. Oh, that line bigger again. Okay. Then it turns again. 1, 2. 1. Turns again for another 2 squares. 1, 2. Turns again for 2. This line does not want to make up its mind. It keeps turning. 1, 2. Oh, Hold on. Okay. 1, 2. It turns again for 2 squares. 1, 2. And then goes back for 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I see at the end, I end up with a shape, and both sides are exactly the same. They're the same size, they're the same shape. When you have a line of symmetry, that's exactly what you want. And look what I could do. All I did on the computer is I told it, flip it upside down, and look what happens if I move my shape up. It matches perfectly. That's what I want when we talk about symmetry. When I have symmetry, I want it to match perfectly. Not kind of, sort of, not close. I want it to match. Okay, this one wants us to use a circle. I'm going to put a circle on any shape or any letter that has that have lines of symmetry. Okay? The letter F. Does the letter F have any lines of symmetry? Is there any place on that letter F that I could fold it or cut it and I'd have two sides that are exactly the same? Nothing. No way I could make it work. If I tried horizontally, if I tried vertically, nothing. What about the letter A? Are there any lines on the letter A I could make where I could fold it and have two perfect halves? Yeah. If I drew a line right down the middle, it would be perfect. Both sides would be exactly the same. What about the letter N? Are there any places on the letter N? No. Can't do any lines vertically. I can't do any lines horizontally or even diagonally. What about Y? Can I see a line of symmetry on the Y? Yeah. So the Y would also have a line of symmetry. Now these last two, these ones they kind of gave us hints for, the A and the Y, but these ones don't give us any hints. We have to figure these out on our own. The letter E. Raise your hand if you think the letter E has a line of symmetry I could use. Okay. The letter E is very, very close to having one. But if I zoom in, it'll be a little more obvious. Look at the top part of the letter E and look at the bottom part. I can see that one side, that missing spot, is a little smaller than the bottom side. So if I drew a line like this, would they be equal and even? No. They'd be close. They'd be very, very close. But they wouldn't be even. What about the letter P? Are there any lines of symmetry in the letter P that I could draw that would make it equal and even on both sides? No. Because it has this round part to it, if I tried to make a line horizontally or vertically or even diagonally, There's no way that I could bend or fold or cut it that would make it equal on both sides. So E and the letter P do not have lines of symmetry. Hey, that kind of rhymed.